Have you ever found yourself sitting in a quiet room, perhaps late at night, when the rest of the world has finally gone to sleep, and you just stare into a mirror for a little too long? At first, you see the familiar face, the eyes you have known since childhood, the curve of the jaw, the slight asymmetry of a smile. But if you hold that gaze, if you really let yourself drift into the reflection without looking away, something strange begins to happen. The familiarity starts to dissolve. The face becomes just a shape, a collection of textures and colors. And suddenly, a profound and slightly unsettling question rises up from the silence of your mind. Who is the one looking? We go through our days feeling like we are a pilot sitting somewhere behind our eyes, driving this body like a biological machine. We feel separate. We feel distinct. We feel like we are in the universe, as if we were placed here on a stage that was already built, actors who arrived long after the theater was constructed. But this feeling of separation is perhaps the greatest illusion ever created. And the story I want to tell you today, the journey we are about to take together, suggests that this feeling is not just wrong, it is the complete opposite of the truth. There is a reality hiding inside the physics of your own body that is so vast and so strange that it has kept physicists awake at night for a century. It is a truth that dissolves the boundary between the observer and the observed. It is the possibility that you are not in the universe at all. You are the universe, waking up to experience itself. Let us begin this journey by looking at what you are actually made of right now in this moment of quiet contemplation. If we could zoom in on that face in the mirror, past the skin, past the cells, past the twisting ladders of DNA in the nucleus of every cell, we would arrive at the world of atoms. The numbers involved here are so large that they become almost meaningless to the human brain, but let us try to hold them in our minds for a moment. A standard human body contains roughly 7 octillion atoms. That is a 7 followed by 27 zeros. To give you a sense of that scale, there are more atoms in your eye right now than there are stars in the entire observable universe. You are a galaxy of particles, bound together by invisible forces, maintaining a shape that you call me. But here is where it gets interesting. These atoms are not new. They were not created when you were born. In fact, they are ancient beyond reckoning. The hydrogen atoms that make up the water in your cells, the hydrogen that accounts for nearly 62% of the atoms in your body, were born just a few minutes after the Big Bang itself. Let that sink in for a moment. The hydrogen in the tear duct of your eye, the hydrogen in the blood pumping through your heart, is 13.8 billion years old. It has been around since the very dawn of time. It traveled through the dark ages of the universe before the first stars ignited. It drifted through the cosmic void for billions of years before being pulled by gravity into a cloud that would eventually become our sun. You are, quite literally, made of the primordial ash of creation. But what about the other atoms? The carbon that forms the backbone of your DNA, the oxygen you are breathing in right now, the iron that colors your blood red. These are younger, but only slightly. They were forged in the crushing hearts of ancient stars that lived and died long before our solar system existed. These giant stars spent millions of years fusing hydrogen into helium, then helium into carbon and oxygen, building up the periodic table in their fiery cores. And when they reached the end of their lives, they exploded in cataclysmic supernovae, scattering these new elements across the galaxy. This is not just a poetic metaphor, it is a literal, physical fact. Every single atom of carbon in your body was once inside a star, Every atom of gold in the ring on your finger was forged in the collision of neutron stars. You are a collection of ancient cosmic debris that has somehow come together, organized itself into an incredibly complex pattern, and started asking questions about where it came from. But there is a deeper mystery here, one that touches on the very nature of existence. If we look closely at these atoms, these 7 octillion ancient particles, we find something shocking. They are almost entirely empty space. If you were to take an atom and blow it up to the size of a football stadium, the nucleus, the solid part where the protons and neutrons live, would be a tiny marble sitting on the 50-yard line. The electrons would be like tiny gnats buzzing around the highest seats in the stands. Everything in between, the vast cavernous distance between the nucleus and the electrons, is empty. It is a void. Physicists estimate that an atom is 99.999999% empty space. This means that if you removed all the empty space from the atoms that make up the entire human race, all 8 billion of us, you could fit the remaining physical matter inside a single sugar cube. Think about that. All the bodies, all the bones, all the brains of every human being on Earth compressed into the size of a die. And yet, when you touch your hand to the table, it feels solid. When you look in the mirror, you see a continuous form. This solidity is an illusion created by the electromagnetic force fields of your atoms pushing against the atoms of the object you are touching. You are a ghost, a phantom of empty space and force fields, wandering through a universe that is mostly void. And yet, despite being made of empty space and dead dust, you feel, you experience. There is a you inside there. This is what philosophers call the hard problem of consciousness. How do you get from dead matter to living experience? You can take a carbon atom and it feels nothing. You can take a hydrogen atom and it feels nothing. You can combine them into a molecule and it still feels nothing. You can build a cell, a tissue, an organ, and still, strictly speaking, you just have a biological machine processing chemical signals. But somewhere, somehow, when you arrange enough of these dead atoms in the particular configuration of a human brain, something miraculous happens. The lights turn on. The universe suddenly has an inside. A photon of light, which has traveled for millions of years from a distant star, enters your eye. It strikes the retina, triggering a chemical cascade that sends an electrical impulse racing down the optic nerve at nearly 200 miles per hour. This electrical signal is just a movement of ions, a physical chain reaction no different in principle than a line of falling dominoes. But when it reaches the visual cortex in the back of your brain, a transformation occurs that science still cannot explain. That electrical signal becomes the experience of blue. It becomes the feeling of brightness. It becomes the image of the star. This transition from the physical movement of atoms to the subjective experience of a mind is the greatest mystery in the universe. It is the point where the objective world of physics meets the subjective world of consciousness. And for centuries, we have assumed that these are two different things. We have assumed that the universe is a physical stage made of matter, and consciousness is something that happens inside it, a byproduct of brain activity, a fleeting spark that flickers on for a few decades and then goes dark. But what if this assumption is wrong? What if the separation between you and the universe is just a trick of perspective? There is a growing unease in the world of theoretical physics, a suspicion that we have been looking at the problem upside down. The more we study the fundamental nature of reality, from the bizarre behavior of quantum particles to the structure of space-time itself, the more it looks like consciousness might not be a late arrival to the cosmic party. It might be the foundation of the party itself. Imagine for a moment that you are a wave on the surface of the ocean. You look around and you see other waves. You see the vast expanse of water. You feel yourself rising and crashing, separate from the other waves, separate from the deep stillness below. You might spend your entire life thinking you are a wave, a distinct entity moving across the surface. But in reality, you are just the ocean in motion. There is no such thing as a wave separate from the ocean. The wave is just the behavior of the water. In the same way, we tend to think of ourselves as entities moving through the universe. We say, I came into this world. But you did not come into this world. You came out of it. You are a behavior of the universe in the same way that a wave is a behavior of the ocean. You are what the universe is doing at this particular location in space and time. The implications of this are profound and perhaps a little terrifying. If you are the universe, then every time you look in the mirror, it is the universe looking at itself. Every time you feel wonder, it is the universe feeling wonder. Every time you feel lonely, it is the universe feeling lonely. We are the eyes through which the cosmos sees itself. We are the ears through which it hears its own harmonies. As the astrophysicist Carl Sagan once famously said, we are a way for the cosmos to know itself. But we can go deeper than Sagan. It is not just that we are a tool for the universe to use. It is that the distinction between the tool and the user, between the observer and the observed, might be an illusion generated by the limitations of our sensory organs. Consider the silence of space. We know that sound cannot travel through a vacuum. Between the planets and the stars, there is a silence deeper than anything we can experience on Earth. And yet, inside your head, right now, there is a voice reading these words. There is a stream of thoughts, memories, and songs. Where is that sound happening? It is happening in a universe that is physically silent. This ability to create an inner world, a simulation, a reality that runs in parallel to the physical world, is a clue. It suggests that the universe has layers of existence that go far beyond the arrangement of atoms. It suggests that there is an interiority to the cosmos, a dimension of feeling and being that is just as real as gravity or electromagnetism. We are about to embark on a journey through the strangest corners of modern physics, from the observer effect in quantum mechanics to the theories of a holographic universe. We will explore the idea that time is an illusion, that death might not be the end of consciousness, and that the universe itself might be a single, vast, living mind. It is a journey that requires us to leave behind our common sense and open ourselves to the impossible. Because, as we will see, the common sense view of the world, the view that we are isolated biological machines living in a dead universe, is almost certainly wrong. The truth is far stranger, far more beautiful, and yes, perhaps a little more terrifying. But it is a terror that brings with it a strange kind of peace. Because if you are the universe, then you are not small, you are not insignificant, and you are never truly alone. As we stare into the mirror of this mystery, we must be willing to let go of the face we see. We must be willing to look past the reflection and ask the question that lies at the heart of existence. What is it that is looking? Is it a person? Or is it something ancient, something vast, something that has been waiting 13.8 billion years to open its eyes? The answer might change everything you think you know about who you are. So, take a deep breath. Let the silence of the room settle around you. Let the dust motes drift in the quiet air. We are going to step through the looking glass. We are going to find out what lies on the other side of the reflection. We often move through the world with a comforting assumption, a silent belief that anchors our sanity. We believe that reality is solid. We assume that the chair you're sitting on, the walls of the room around you, and the street outside your window continue to exist exactly as they are, even when you close your eyes. We believe that the universe is a stage that was built long before we arrived and will remain long after we are gone, indifferent to our presence. We assume that if every human being, every animal, and every conscious observer were to suddenly vanish, the planets would keep orbiting, the waves would keep crashing on empty shores, and the stars would keep shining in the vacuum of space. It feels intuitively true. It feels right. But in the early decades of the 20th century, a group of physicists stumbled upon a discovery that shattered this assumption so completely that we are still trying to pick up the pieces today. They found evidence suggesting that the universe is not a fixed stage at all. It suggests that reality, at its most fundamental level, might not fully exist until it is observed. This brings us to one of the most unsettling questions ever asked by science, a question posed by Albert Einstein in a moment of frustration with quantum mechanics. Do you really believe the moon is not there when you are not looking at it? To understand why a genius like Einstein would ask such a seemingly absurd question, we have to descend into the subatomic world. We have to leave behind the world of chairs and tables and enter the realm of the electron and the photon. Down here, the rules of common sense do not just bend, they break. In this microscopic kingdom, particles do not behave like tiny, distinct marbles. They behave like ghosts. They behave like possibilities. And the most famous demonstration of this ghostly behavior is an experiment that you might have heard of, but whose implications are rarely fully felt. The double-slit experiment. Imagine for a moment that you are standing in front of a wall with two vertical slits cut into it. Behind that wall is a second screen, a detector that records where things land. Now, imagine you have a machine that fires tennis balls. You aim at the slits and start firing. Some balls bounce off the wall, but some pass through the left slit and hit the back screen. Others pass through the right slit and hit the back screen. If you look at the pattern on the back detector, you see two distinct bands of marks, one corresponding to the left slit, one to the right. This makes perfect sense. Tennis balls are physical objects. They go through one hole or the other. Now, let us shrink our tennis balls down to the size of electrons, the tiny particles that orbit the nucleus of every atom in your body. We fire these electrons at the two slits. Logic dictates we should get the same result. Two bands on the back screen. But we don't. When we look at the back screen, we do not see two bands. We see an interference pattern, a complex series of many bands rippling out like waves on a pond. This pattern can only happen if the electron goes through both slits at the same time, interferes with itself like a wave of water, and then lands on the screen. This is already impossible for the human mind to visualize. How can a single particle be in two places at once? How can a single point of matter behave like a rippling wave? But the mystery gets deeper. Physicists, confused by this result, decided to place a detector, a watcher, right next to the slits to see which one the electron actually went through. They wanted to catch the ghost in the act. They turned on the detector, They fired the electron. And in that moment, the universe did something that feels like magic. The interference pattern disappeared. The electron stopped behaving like a wave. It went through just one slit, like a tiny marble, and created the simple two-band pattern of the tennis balls. Let us pause and really feel the weight of this. The moment we looked, the behavior changed. The moment conscious observation, or a measurement linked to an observer, was introduced. The electron snapped from a wave of infinite possibilities into a single, solid particle. It is as if the universe knew it was being watched. It is as if the particle was waiting for an audience before deciding where to be. This phenomenon is known as the collapse of the wave function. Before the observation, the electron exists in a state of superposition, a hazy cloud of probability, where it is partly in the left slit, partly in the right slit, and partly nowhere at all. It is not real in the way we think of reality. It is a ghost of potential. But when the eye of the observer turns toward it, that ghost is forced to manifest. It is forced to choose. The act of looking creates the reality of the location. This discovery sent shock waves through the scientific community that are still reverberating today. The Danish physicist Niels Bohr, one of the fathers of quantum mechanics, famously said, "Everything we call real is made of things that cannot be regarded as real." He was pointing to the fact that the solid world you see around you, the book in your hands, the floor beneath your feet, is built on a foundation of shifting, ghostly probabilities that only harden into things when they interact with an observer. This completely dissolves the separation between you and the universe. You're not just a passive camera taking pictures of a world that is already there. You are, in some mysterious way, the projector. Your consciousness, your act of observation, is the catalyst that forces the universe to materialize. But how far does this go? Does it only happen to tiny electrons in a lab? Or does it apply to the massive structures of the cosmos? In the 1970s, the physicist John Archibald Wheeler proposed a thought experiment that stretches this concept across the entire universe and across time itself. It is called the delayed choice experiment. Imagine a photon of light emitted by a distant quasar, a galaxy billions of light years away. This light travels across the cosmos for billions of years. On its journey, it encounters a massive galaxy. The gravity of this galaxy acts like a lens, bending the light. The photon can go around the left side of the galaxy or the right side to reach Earth. This is a cosmic version of the double slit. The photon has to choose a path. Now, billions of years later, that photon arrives at Earth, where an astronomer is waiting with a telescope. Wheeler showed that the choice the astronomer makes today, how they decide to measure that photon, determines the path the photon took billions of years ago. If the astronomer sets up the equipment one way, the photon acts like a particle that traveled a single path. If they set it up another way, the photon acts like a wave that traveled both paths simultaneously. This implies something absolutely mind-bending. The act of observation we perform now creates the history of the universe then. It suggests that the past is not fixed. The history of the cosmos, the burning of ancient stars, the collision of galaxies, the journey of primordial light, might exist only as a cloud of probability until a conscious mind arises to observe it. This leads us to a terrifying and beautiful possibility. Perhaps the universe needs us. For centuries, science has taught us humility. It has told us that we are accidental specks on a tiny rock, irrelevant to the grand machinery of the cosmos. It has told us that the universe is vast, cold, and indifferent. But quantum mechanics whispers a different story. It whispers that without an observer, the universe is just a ghostly sea of potential, a dream that has not yet been dreamed. It suggests that consciousness is not an accidental byproduct of matter, but the fundamental ground that allows matter to exist. We are the mechanism by which the universe collapses from a state of infinite possibility into a state of concrete reality. We are the anchors. We are the witnesses that make the story real. Think about the silence of a forest when a tree falls. The old philosophical riddle asks, if a tree falls in a forest and no one is around to hear it, does it make a sound? Classical physics would say yes, it produces sound waves. But quantum mechanics offers a stranger answer. It suggests that if no one is there to observe it, there might not even be a sound in the way we understand it. There is only a disturbance in the quantum field, a potentiality of sound, waiting for an ear to collapse it into the experience of a crash. The universe is a symphony that requires a listener to exist. Without the listener, there is no music, only the silence of waiting. This is a heavy burden to carry. It places the responsibility of existence squarely on the shoulders of consciousness. But it is also a source of profound connection. If you are the observer that collapses reality, then you are woven into the very fabric of the cosmos. You are not separate from the electron you observe. You are a partner in its existence. The physicist Erwin Schrödinger, famous for his cat thought experiment, believed deeply in this unity. He wrote, "The total number of minds in the universe is one. In fact, consciousness is a singularity, phasing within all beings." He believed that the feeling of having a separate individual mind is an illusion, a trick of the light. In reality, there is only one universal mind, looking out through billions of pairs of eyes, collapsing the wave function of the universe in billions of different locations, creating the rich, textured tapestry of reality we experience. So, when you look at the stars tonight, remember that you're not just seeing them. You are, in a very real quantum sense, helping to create them. Your gaze travels across the light years, and where it lands, the universe snaps into focus. You are the watcher at the gates of reality. The vast, cold emptiness of space is not truly empty. It is filled with the potential for existence, waiting for you to turn your head and bring it to life. This is the participatory universe. It is a universe where the observer and the observed are a single, tangled loop. The universe creates you, and you create the universe. It is a cosmic dance where neither partner can exist without the other. But if consciousness creates reality, what happens when consciousness ends? What happens when the observer closes their eyes for the last time? This is the question that haunts us all. If the world depends on our observation, does the world disappear when we die? Or is death just another shift in the wave function, a transition from one state of probability to another? There is a theory in physics called quantum immortality, a concept so strange that many physicists refuse to discuss it, yet the math allows it. It suggests that because of the way quantum probabilities work, the subjective experience of consciousness might never actually be able to cease. We might be trapped in an eternal moment of observation, sliding through infinite branches of reality, forever the witness, forever the anchor. We will explore that terrifying idea later in our journey. For now, let us rest in the wonder of the observer effect. Let us sit with the knowledge that our attention is a force of nature. We are not powerless. We are not insignificant. We are the necessary ingredient. The universe has spent 13.8 billion years building a structure complex enough to support a mind, just so that it could finally look at itself and say, I am here. You are that I am. You are the voice of the cosmos declaring its own existence. The next time you feel small, the next time you feel overwhelmed by the scale of the world, remember the electron. Remember the double slit. Remember that without your eyes to see it, the moon might be nothing more than a ghost. You are the guardian of reality. You are the one who keeps the world solid. And in the silence of that realization, a new question begins to form, rising from the quantum foam. If we are the creators of this reality, what lies beyond the edges of our vision? What exists in the spaces we are not looking at? What monsters or miracles live in the uncollapsed waves of the dark? To answer that, we have to look at what connects us all. We have to look at the invisible web that ties every atom in your body to every atom in the farthest star. We have to talk about entanglement. Because if you think the observer effect is strange, wait until you learn that space itself might be an illusion. Wait until you learn that there is no here and there, only a single, unified everywhere. The journey is only beginning, and the rabbit hole goes much deeper than we ever imagined. We live our lives defined by distance. We measure the space between us and the people we love in miles or kilometers. We measure the journey to our jobs in minutes and hours. We look up at the night sky and feel a crushing sense of isolation because the stars are so terribly far away. Proxima Centauri, our nearest stellar neighbor, sits more than 25 trillion miles from where you are sitting right now. The light from the Andromeda galaxy, traveling at the fastest speed in the universe, takes 2.5 million years just to reach your retina. This vastness makes us feel small. It makes us feel lonely. It makes us feel like tiny, isolated islands floating in an endless ocean of empty black space. We believe that for one thing to affect another, they must touch, or at least send a signal across the gap between them. If I want to move a book, I must push it. If I want to speak to you, sound waves must travel through the air to your ear. This is the law of locality, the common sense idea that things only interact with their immediate surroundings. It is the rule that keeps the universe organized, ensuring that causes happen before effects and that events in one corner of the cosmos do not inexplicably chaos in another. But what if I told you that this distance is a lie? What if I told you that separation is an optical illusion, a stubborn trick of the biological mind, and that deep down, in the basement of reality, nothing has ever truly been separated from anything else? This brings us to the phenomenon that Albert Einstein famously derided as spooky action at a distance. It is a concept so bizarre, so counterintuitive, that it threatened to tear apart the very foundations of physics in the 20th century. It is called quantum entanglement. To understand it, we have to go back to the subatomic casino, to the world of particle spins. Imagine you have two electrons. In the strange language of quantum mechanics, these particles have a property called spin, which is not quite like a spinning top, but more like a magnetic orientation. They can be spinning up or spinning down. Now, imagine we bring these two electrons together and let them interact in a way that entangles them. They become a single quantum system. Their fates are now linked. The mathematics tells us that if one is spinning up, the other must be spinning down to balance the system. But here is the catch. Until we measure them, neither of them has decided which way to spin. They are both in a superposition of spinning up and down simultaneously. They are undefined. Now, let us separate these two entangled electrons. We leave one here on Earth in a laboratory in Switzerland. We take the other one and put it on a spaceship. We fly it all the way to the other side of the observable universe, billions of light years away, to a galaxy on the edge of the cosmic horizon. They are now separated by a distance that light would take billions of years to cross. According to the rules of classical physics and the speed limit of the universe, these two particles should be completely independent. What happens to one cannot possibly affect the other instantly, because nothing can travel faster than light. But quantum mechanics says otherwise. It says that the moment a scientist on Earth measures their electron and finds it spinning up, the electron on the other side of the universe instantly, at that exact moment, with zero time delay, snaps into the state of spinning down. How does the second particle know? How does a message travel across billions of light years in 0 seconds? The answer is that no message traveled. There was no signal sent. There was no movement across space. The two particles, despite being separated by a vast ocean of emptiness, are still, in some fundamental way, the same object. Space has failed to separate them. This implies that at the deepest level of reality, spatial distance does not exist. The concept of here and there is just a convenient fiction for beings like us who need to navigate a macroscopic world. Under the hood, the universe is not a collection of separate objects distributed across space. It is a single, unified web where everything touches everything else. Einstein hated this idea. He spent the latter part of his life trying to prove it wrong. He argued that there must be hidden variables, secret instructions inside the particles that determine their state beforehand, like a pair of gloves in two boxes. If you open one box and find a left glove, you know the other is a right glove. Not because of magic, but because they were always that way. He wanted to save the universe from the chaos of instant connection. He wanted to preserve the comforting reality of separation. But the universe did not want to be saved. In the decades following Einstein's death, physicists developed ways to test this. The most famous of these is Bell's theorem, a brilliant mathematical proof that allowed us to check if the gloves were predetermined or if they were truly deciding in the moment. And experiment after experiment, culminating in the work that won the Nobel Prize in Physics in 2022, has proven Einstein wrong. The particles do not have secret instructions. They are genuinely undecided until the moment of observation, and they genuinely influence each other instantaneously across any distance. The implications of this are staggering. If two particles can be entangled, what about 3? What about 1,000,000,000,000? What about a universe? Let us wind the cosmic clock back 13.8 billion years. We arrive at the moment of the Big Bang, the singularity. At this instant, all the matter and energy that would ever exist, every electron in your heart, every photon in the sun, every quark in the most distant galaxy, was compressed into a point smaller than a single atom. Everything was touching, everything was interacting, everything was entangled, and quantum theory suggests that entanglement is not easily broken. It persists. It implies that even as the universe expanded, blowing up like a majestic balloon and scattering matter across the dark void, the deep quantum connection remained. This means that on a fundamental level, you are entangled with the stars. The atoms in your left hand are entangled with the atoms in a nebula in the Orion constellation. The electrical impulses in your brain are entangled with the dust storms on Mars. The feeling of separation you experience, the sensation that you are an individual enclosed in a bag of skin, cut off from the rest of the world, is a persistent, convincing, but ultimately false hallucination. You are not a stranger in the cosmos. You are a thread in a tapestry that has never been torn. The universe is not a collection of separate things. It is a single, breathing organism. When you look at a flower, you are not seeing an object outside of yourself. You are seeing another part of the same quantum field that creates you. You are the universe looking at itself from a slightly different angle. This dissolves the loneliness of the human condition. We often feel that we are isolated minds, trapped in solitary confinement behind our eyes, unable to truly touch another soul. But physics tells us that the boundaries between us are porous. If our particles are entangled, then at a level deeper than speech, deeper than touch, deeper even than thought, we are already connected to everyone we have ever loved and everyone we have ever lost. The separation is only on the surface. Deep down, the roots of our being are tangled together in the dark soil of the quantum vacuum. We are like islands in the sea, separate on the surface, but connected in the deep. Or perhaps we are like the fingers of a hand, wiggling independently, thinking we are free, unaware that we are all part of the same palm. There is a concept in theoretical physics called the universal wave function. It was proposed by Hugh Everett, the man who gave us the many worlds interpretation. It suggests that since everything interacts with everything else, we cannot really talk about the wave function of an electron or the wave function of a cat. We can only talk about the wave function of the universe, one single mathematical equation that describes every particle, every position, and every moment in time as a single unified state. In this view, there are no parts. There is only the whole. You are not a noun. You are a verb. You are a process. You are a ripple in the universal field. And just as you cannot remove a ripple from the water without removing the water itself, you cannot be removed from the universe. You are the universe happening. This changes how we think about the empty space around us. We tend to think of space as a void, a nothingness that separates objects. But in the light of entanglement, space becomes a medium of connection. It is not an empty stage. It is a bridge. The vacuum is alive with potential, a seething ocean of virtual particles popping in and out of existence, stitching the fabric of reality together. The silence of space is not the silence of absence. It is the silence of a held breath, a tension that holds the stars in place and binds the galaxy together. When you walk through a room, you are not moving through space. You are moving within the web. You are pulling on the threads of the cosmos with every step you take. And this brings us to a profound realization about the nature of influence. If everything is entangled, then every action matters. Every thought, every movement, every shift in consciousness sends a tremor through the web. We are not isolated observers watching a movie. We are participants. We are co-creators. The butterfly effect in chaos theory tells us that a butterfly flapping its wings in Brazil can cause a tornado in Texas. But quantum entanglement suggests something even more intimate. The butterfly and the tornado are, in some sense, the same thing. The distinction between the cause and the effect is blurred. The universe is a holistic system where the whole is present in every part. This perspective aligns beautifully with ancient wisdom traditions that have argued for the illusion of separation for millennia. The mystics who spoke of oneness, the Buddhists who speak of interdependent co-arising, the Hindus who say, Tattvam Asi, thou art that. Were they glimpsing this quantum truth through the lens of deep meditation? Did they intuit, through the silence of their own minds, what we are now discovering with our particle colliders and supercomputers? It seems that the deeper we look into the objective nature of reality, the more it resembles the subjective insights of the awakened mind. Science and spirituality, long thought to be enemies, are meeting in the middle of the tunnel, and the message they are both whispering is the same. You are not alone. You never were. So, take a moment to look around you. Look at the walls. Look at the sky. Look at the person sitting next to you. And try to see them not as separate objects, but as extensions of yourself. Try to feel the invisible threads that bind your atoms to theirs. The universe is not a collection of fragments. It is a seamless garment. The distance is a dream. The separation is a shadow. The reality is unity. And if space is an illusion, if the distance between here and there is not fundamental, then what about the distance between now and then? What about the wall that separates the past from the future? If the universe creates space to stop everything from happening to you, does it create time to stop everything from happening at once? As we stand here, connected to the furthest star and the oldest atom, a new question arises, a question that challenges the most stubborn illusion of all, the flow of time. We feel time passing. We feel the seconds ticking away, lost forever into the past. We fear the future because it is unknown. But what if the past is not gone? What if the future is already here? What if time is just another dimension of the frozen block of the universe, and your consciousness is just a spotlight moving across a landscape that is already complete? If space is a lie, time might be the next mask to fall, and what we find behind it might be the key to understanding eternity itself. We wake up every morning to the rhythmic ticking of the clock, the silent metronome that governs our existence. We feel the seconds slipping through our fingers like grains of sand, lost forever to the dark abyss of the past. We rush through our days, chased by the shadow of the future, a realm of uncertainty and potential that has not yet arrived. This sensation of flow, this feeling that time is a river carrying us from a birth we cannot remember to a death we cannot avoid, is the most fundamental experience of our lives. It feels absolute. It feels undeniable. We mourn the past because we believe it is gone, dissolved into non-existence. We fear the future because we believe it is unwritten, a chaotic void waiting to be filled by our choices and chance. But what if I told you that this entire emotional landscape, this deep-seated intuition about the nature of reality, is a lie? What if I told you that in the eyes of physics, the river does not flow? The past is not dead. The future is not empty. They are simply places just like left and right, up and down, existing simultaneously in a vast, frozen crystal of eternity. To understand this shattering truth, we must climb to the shoulders of the giant who changed everything, Albert Einstein. Before Einstein, we viewed time as a universal clock, ticking at the same rate for everyone, everywhere. A second on Earth was a second on Mars, was a second in the Andromeda galaxy. Time was the stage upon which the universe danced. But Einstein, in his special theory of relativity, revealed something that terrified the philosophers of his day. He showed that time is not a constant stage. It is a flexible, malleable fabric woven together with space into a single four-dimensional manifold called space-time. And most importantly, he showed that the distinction between the past, the present, and the future is not a fundamental property of the universe, but a persistent illusion created by our perspective. Imagine for a moment that you are holding a loaf of bread. This loaf represents the entire universe. You can slice this loaf in many different ways. If you slice it straight down, you get a cross-section that represents the present moment, the state of the universe right now. Everything in that slice happens simultaneously, but Einstein showed that motion affects how we slice the loaf. If you are standing still, you slice the bread straight. But if you are moving, if you are driving a car or flying in a spaceship, your slice of the universe is tilted. You are cutting the bread at an angle. This means that what is in your present slice includes parts of the loaf that are in the past for someone else, and parts that are in the future for someone else. This concept is known as the relativity of simultaneity, and its implications are mind-bending. Let us visualize the famous Andromeda paradox to truly grasp the scale of this. Imagine an alien civilization living in the Andromeda galaxy, 2.5 million light-years away. Now, imagine two aliens, let us call them X and Y, walking on a planet in that galaxy. Alien X is walking slowly towards Earth. Alien Y is walking slowly away from Earth. Because they are moving in opposite directions relative to us, their slices of the space-time loaf are tilted in opposite directions. For Alien X, who is walking towards us, their now slice tilts into our future. In their present moment, the Earth they are simultaneous with is an Earth where you might be dead, where cities have risen and fallen, where the future has already happened. But for Alien Y, who is walking away from us, their now slice tilts into our past. In their present moment, the Earth they are connected to is an Earth where you might not have been born yet, or where you are a child playing in the backyard. Think about what this means. It implies that your past, your present, and your future all exist strictly as valid coordinates in space-time. If an observer can exist for whom your future is there now, then your future must already be real. It must already be there, waiting for you. This leads physicists to the concept of the block universe. In this view, the universe is not a three-dimensional world that changes over time. It is a four-dimensional block that contains all of history and all of the future at once. The Big Bang is not an event that happened long ago. It is simply one edge of the block. The heat death of the universe is not an event that will happen. It is the other edge. And your entire life, from your first breath to your last, is a single, immutable worm, a thread frozen in the amber of space-time. This is a terrifying thought for the part of us that believes in free will. It suggests that the script is already written. The movie is already in the can. We are just watching the frames flicker by. Einstein himself found a strange comfort in this. When his close friend Michel Besso died, Einstein wrote a letter to Besso's family that contained one of the most profound sentences in the history of science. Now, he has departed from this strange world a little ahead of me. That means nothing. People like us who believe in physics know that the distinction between past, present, and future is only a stubbornly persistent illusion. Einstein was telling them that Besso was not gone. He was simply in a different part of the block, just as New York is in a different place than London. You do not grieve for New York just because you are in London. You know, it still exists. In the block universe, every moment you have ever lived, that kiss in the rain, that summer afternoon in childhood, that moment of heartbreak, is eternal. It is never lost. It is always there, fixed forever in the geometry of eternity. But if the universe is a frozen block, dead and static, where does the feeling of flow come from? Why do we feel like we are moving? Why does the now feel so incredibly real, vividly different from the memory of the past or the imagination of the future? This brings us back to the mystery of consciousness. Many physicists and philosophers believe that the flow of time is not a property of physics, but a property of the mind. They propose the moving spotlight theory. Imagine the block universe as a dark, silent cathedral filled with statues representing every moment of history. The statues are stationary. They do not move. But there is a light, a single focused beam, that moves through the cathedral, illuminating one statue at a time. When the light hits a statue, that moment becomes now. It becomes alive. It becomes an experience. When the light moves on, the statue returns to the dark, but it does not vanish. It remains exactly as it was. In this metaphor, your consciousness is the light. You are the spotlight traveling through the frozen landscape of space-time. The universe is not happening. You are happening to the universe. You are crawling through the block, animating it moment by moment, creating the illusion of a story from a static manuscript. This suggests that the you of 10 years ago is not a memory. It is a real entity, trapped in that slice of time, forever experiencing that moment. And the you of 10 years from now is already there, waiting for the light of consciousness to arrive and wake it up. This idea is radically empowering, but also deeply unsettling. It implies that you are not a single person moving through time. You are a long, snake-like object stretching through the fourth dimension. The you reading this right now is just a cross-section, a single slice of the worm. But it also raises a question that chills the bone. What moves the light? If the block is frozen, what is the force that propels consciousness forward? Why does the spotlight move from the past to the future? Why can we not stop it? Why can we not reverse it? This is the arrow of time, often linked to entropy, the tendency of the universe to move from order to disorder. But even entropy is just a pattern in the block. It does not explain the experience of the flow. There is a growing suspicion that this movement might be the only true free will we have. Perhaps we cannot change the block. The events are fixed. But perhaps we can change how we observe it. Perhaps the quality of the light, the attention, the awareness, the depth of presence, is what we contribute to the cosmos. If the universe is a song recorded on a vinyl record, the notes are fixed. We cannot change the melody, but we are the needle. We are the vibration that turns the silent groove into music. Without us, the block universe is just a silent library of unread books. With us, it is a story, and here lies the deepest mystery of all. If consciousness is the light moving through the block, does the light die when it reaches the end of the worm? When you reach the coordinates of your physical death, does the spotlight switch off? Or does it simply reset? Does it move to another worm? Or, perhaps strangest of all, does it realize that it was never a spotlight at all, but the light of the entire cathedral? Some interpretations of quantum mechanics, like the timeless universe models, suggest that time fundamentally does not exist at the quantum level. The Wheeler-DeWitt equation, which describes the quantum state of the entire universe, does not contain a variable for time. It suggests that the universe is essentially static. The change is an illusion of our perception, a blurry artifact of our inability to see the whole picture. If this is true, then eternity is not a long time. Eternity is the absence of time. It is the state of pure being, the isness that underlies the illusion of was and will be. When we sit in meditation, when we quiet the mind and stop chasing the future or replaying the past, we sometimes catch a glimpse of this. We touch the eternal now. In that state of deep silence, the ticking clock fades away. The anxiety of the future dissolves. The regret of the past evaporates, and we are left with a profound sense of presence, a feeling that this moment, this breath, this heartbeat, this ray of sunlight is the only thing that has ever existed. Perhaps the mystics are right. Perhaps the kingdom of heaven is not a place you go to after you die, but a dimension of reality that is always here, hidden behind the veil of time. Perhaps enlightenment is simply the realization that you are not the traveler in the river, but the water itself, ancient and unchanging. So, as you go about your day, try a simple experiment. Look at your hand. Realize that the hand of your childhood is still there, existing in the past coordinates of space-time. Realize that the hand of your old age is already there, waiting in the future coordinates. And realize that the you looking at it right now is the bridge between them. You are the focal point where the universe becomes aware of itself. You are the eye of eternity blinking in the stream of time. This perspective shifts our relationship with loss. We grieve because we think moments are destroyed. We think the people we lose are erased. But in the cathedral of eternity, nothing is ever destroyed. Every smile, every word, every embrace is preserved forever in the amber of the cosmos. They are safe. They are written into the very geometry of reality, indestructible and permanent. We may not be able to visit them with our current biological bodies, limited as we are to moving forward along the arrow of time. But they are there. The universe remembers everything because the universe is everything all at once. And if the past is safe, then the future is safe too. We spend so much energy worrying about what is to come, trembling before the unknown. But if the block universe is real, the future is not a chaotic storm we have to navigate. It is a landscape that is already formed. The mountain you have to climb is already there. The view from the top is already waiting. You just have to keep walking. You just have to keep shining the light. The story is written, and it is a story of a universe waking up to itself through you. But this brings us to the edge of an even greater precipice. If time is an illusion, and separation is an illusion, and the solid world is an illusion, what is left? What is the fundamental stuff that makes up this hologram we call reality? If we strip away the time, strip away the space, strip away the matter, what remains? The answer seems to be information, pure, abstract information. And this leads us to the darkest, densest, most mysterious objects in the universe. The places where time stops completely. The places where space is torn apart. The places that might be the hard drives of the cosmos. We must turn our gaze to black holes, because it is there, at the event horizon, that we might find the proof that reality is not 3D at all. We might find that we are living on the flat surface of a cosmic bubble, and everything we see is just a projection, a hologram. The journey into the illusion of time has shown us that our lives are eternal sculptures in space-time. But the journey into the holographic universe will show us that the sculpture itself might be made of nothing but bits and bytes of quantum code. The rabbit hole goes deeper, the mystery gets stranger, and the silence at the center of it all gets louder. Are you ready to see what lies at the bottom of the drain, in the darkest corners of the cosmos, where the fabric of space-time is stretched to its absolute breaking point? There exist monsters that defy the laws of physics as we understand them. We have spent centuries looking up at the stars, admiring their light, charting their courses, and imagining them as the fundamental building blocks of the galaxy. But the stars are merely the decoration, the true architects of the universe, the silent rulers that shape the destiny of galaxies and perhaps reality itself, are the objects that emit no light at all. We are talking, of course, about black holes. For a long time, we thought of them simply as cosmic vacuum cleaners, destructive drains that swallowed everything unfortunate enough to get too close. We feared them as engines of death. But in the last few decades, a terrifying realization has dawned on the physics community. Black holes are not just trash compactors. They are hard drives. They are the Rosetta Stones of the cosmos. And what is written on their surface might be the proof that the three-dimensional world you see around you, the depth of the room, the distance to the horizon, the solidity of your own body, is a hologram, a compelling, high-resolution, touchable illusion projected from a two-dimensional surface at the edge of the universe. To understand how we get from a dead star to a holographic universe, we must journey to the center of the largest galaxy we have ever discovered, the giant IC 1101. As we discussed earlier, at the heart of this cosmic leviathan sits a supermassive black hole of incomprehensible scale. It contains the mass of roughly 50 billion suns. That is 50 billion times the mass of our entire solar system, crushed into a single dark sphere. The event horizon of this monster, the point of no return, stretches out for roughly 150 billion kilometers. If you placed it in the center of our solar system, it would swallow everything out past the orbit of Pluto and the Kuiper Belt. It is a region of shadow so vast that light itself, the fastest thing in the universe, takes days just to cross its diameter. It is an abyss that stares back. Let us imagine for a moment that you are a brave, indestructible astronaut attempting to approach this event horizon. As you drift closer, the first thing you notice is the distortion of the sky. The gravity is so intense that it bends light like a lens. The stars behind the black hole are smeared into rings and arcs, creating a funhouse mirror effect that warps the heavens. But the strangeness is not just visual. It is temporal. As we learned from Einstein, gravity is not just a force that pulls on matter, it pulls on time. The stronger the gravity, the slower time moves. As you get closer to the horizon, to the edge of the cliff, your watch starts to tick slower relative to the universe outside. If you could look back at Earth, you would see history speeding up. You would see civilizations rise and fall in the blink of an eye. You would see stars born and dying like fireflies flashing in the night. You are entering a region where time is being strangled by the sheer weight of the darkness. Now, let us look at you from the perspective of a friend watching from a safe distance far away. As you fall toward the black hole, they see something bizarre happen. They never see you cross the edge. As you approach the event horizon, the light coming from your body gets stretched, becoming redder and dimmer. Your movements slow down until you seem to freeze in place, fading slowly into the infrared, stuck forever on the threshold of the abyss. To the outside observer, you never truly leave the universe. You are plastered onto the surface of the black hole, preserved as a fading image for all eternity. But from your perspective, you fall right through. You notice nothing special as you cross the line. The darkness engulfs you, and you continue your plummet toward the singularity, the point of infinite density at the center where space and time cease to exist. This discrepancy, The fact that the outside observer sees you stop at the surface, while you feel yourself continue into the interior, is the first clue that the inside and the surface are mysteriously linked. For decades, this was just a curiosity. But in the 1970s, the legendary physicist Stephen Hawking threw a wrench into the machinery of physics. He discovered that black holes are not truly black. Due to quantum effects near the event horizon, particles popping in and out of existence, black holes slowly leak radiation. They glow with a faint heat. Over unfathomable timescales, we are talking about a 1 followed by 100 zeros years. Even a monster like the one in IC 1101 will eventually evaporate. It will shrink and shrink until it disappears in a final burst of energy. And this created a crisis that threatened to destroy physics itself. The problem is called the information paradox. In our universe, information is supposed to be indestructible. If you burn a book, the information is not strictly lost. In principle, if you could capture every photon of light, every particle of ash, and every molecule of smoke, you could reconstruct the book. The arrangement of atoms is scrambled, but it is not deleted. Quantum mechanics relies on this principle. The past determines the future, and the future preserves the past. But if a book falls into a black hole, and then the black hole evaporates into featureless radiation, where did the book go? If the black hole disappears completely, the information seems to be erased from the universe. This would mean that the past is deleted. It would mean that physics is fundamentally broken. The solution to this paradox, proposed by physicists like Leonard Susskind and Gerard 't Hooft, is one of the most radical ideas in human history. They realize that the information of the book, or the astronaut, or the star that falls into the black hole is not lost. It is stored. But it is not stored inside the volume of the black hole, like marbles in a bag. It is stored on the surface, on the event horizon itself. Imagine taking a soup can and peeling off the label. The label is a two-dimensional sheet, but it describes what is inside the three-dimensional can. Susskind and 't Hooft argued that when an object falls into a black hole, its information is scrambled and plastered onto the event horizon in two-dimensional bits, like a coat of digital paint. The three-dimensional object is translated into a two-dimensional code. This was a massive breakthrough. It saved quantum mechanics. The information is safe. It is just encoded on the shell. But then came the terrifying realization. The mathematics that describes this surface storage does not just apply to black holes. It applies to any region of space with a boundary. It applies to the universe itself. If you take any volume of space, a room, a planet, a galaxy, the maximum amount of information you can pack into that volume is determined not by how much space is inside, but by the surface area of the boundary surrounding it. This suggests that the inside, the three-dimensional world we think we live in, is mathematically equivalent to the two-dimensional boundary. The 3D world is a projection of 2D data. This is the holographic principle. It suggests that the universe is like a hologram on a credit card. On the card, you see a flat 2D pattern of swirls, but when light hits it, a 3D image pops out. You can look at it from different angles. You can see depth. You can see parallax. It looks real, but if you try to touch the depth, you touch the flat card. The reality is the 2D surface, the 3D image, is an illusion of light and perspective. In this cosmological version, the surface might be the cosmological horizon, the erratic edge of the observable universe, and everything inside, including you, me, the stars, and the space between them, is the projection, We are the 3D ghosts of 2D data. Let us try to feel the weight of this. Look at your hand again. It looks solid. It looks like it has volume. It looks like it occupies space. But if the holographic principle is correct, every cell, every atom, every electron in that hand is actually a bit of information encoded on a distant two-dimensional screen at the edge of the cosmos. The you that feels pain, the you that falls in love, the you that wonders about the stars is a user interface. You are the avatar. The real you, the source code, is written on the walls of the universe. This implies that space itself, the depth, the up and down, the forward and back, is not fundamental. It is a derived property. It is a sensation created by the processing of information. Just as a video game character feels like they are moving through a 3D world, but is actually just a stream of zeros and ones on a 2D hard drive, we are navigating a simulation generated by the quantum code of the horizon. This idea echoes the ancient allegory of Plato's cave. 2,000 years ago, the philosopher Plato imagined prisoners chained in a cave, facing a blank wall. Behind them was a fire, and puppets were being moved in front of the fire, casting shadows on the wall. The prisoners, having never seen the outside world, believed the shadows were the reality. They gave them names. They studied their movements. They built their lives around the shadows. We are those prisoners, but our cave is the universe, and the shadows are three-dimensional. We believe in the reality of the chair, the table, the planet. But they are just shadows cast by a light we cannot see, from a source we cannot comprehend. The physicist Jacob Bekenstein, who laid the groundwork for this theory, calculated exactly how small the pixels of this reality are. They are called the Planck length. A Planck length is to an atom what an atom is to the entire Earth. It is the smallest possible unit of space. This is the resolution of our universe. We are living in a pixelated reality, but the pixels are so fine that it looks smooth to us. The universe is not continuous. It is digital. It is made of discrete bits of information. It from bit, as the physicist John Archibald Wheeler phrased it. Every it, every particle, every force field derives its existence from bit, a binary yes or no answer to a measurement question. This brings us to a haunting question. If the universe is a hologram and we are the projection, what is the light? What is the force that shines through the 2D data and creates the 3D experience? Is it consciousness? Is the observer we talked about in previous chapters the laser beam that reconstructs the hologram? If there were no observer, would the universe just be a scramble of data on the horizon, a silent hard drive with no monitor? It seems that we are back to the central mystery, the inseparable link between the mind and the cosmos. The data needs a reader. The code needs a compiler. You are that compiler. Your mind is the machine that renders the universe into existence. And if we are information, if we are code, then we are, in a sense, immortal. You can destroy a computer, but you cannot destroy the math that makes the software run. The code exists in the abstract realm of logic. Perhaps death is just the de-resolution of the avatar. The data returns to the horizon. The wave returns to the ocean. The information that defines the pattern of you is written indelibly in the archives of the cosmos. Nothing is ever truly deleted in a quantum universe. But there is a darker implication to the holographic principle. If we are a simulation, a projection, does that mean we are fake? Does it mean our feelings are not real? No. It means that real is a much bigger word than we thought. A hologram is real. Information is real. In fact, information might be the most real thing there is. Matter is just the shape that information takes. Energy is just the movement of information. The universe is not made of stuff. It is made of meaning. It is a language being spoken in the silence of the void. So, when we look at the black hole in the center of IC 1101, we are not looking at a destroyer. We are looking at a teacher. We are looking at the limit of our reality. The event horizon is the edge of the screen. And as we stare into that darkness, we are beginning to realize that the screen is not blank. It is full of answers. It is whispering to us that the world is more magic than machine. It is telling us that we are deeper than our bodies, wider than our space, and older than our time. But if the universe is digital, if it is granular, if it is made of bits, is it possible that it was programmed? Are we living in a computation? Is the cosmos a giant quantum computer calculating its own future? And if so, who built the computer? Or is the computer thinking itself into existence? This leads us to the wildest frontier of all, the simulation hypothesis and the idea of the panpsychic universe. If the hardware is a hologram, is the software a mind? Is the universe thinking? We have looked at the mirror and seen the observer. We have looked at the particles and seen the ghost. We have looked at the black holes and seen the hard drive. Now we must look at the code itself. We must ask if the laws of physics are the thoughts of a god or the algorithms of a machine. The distinction might not be as clear as you think. As we prepare to dive into the digital mind of God, remember, you are not just a user in this system. You are part of the operating system. You are the universe calculating itself. If the universe is fundamentally made of information, if reality is a hologram projected from the edge of the cosmos, and if every particle is just a bit of binary code answering a yes or no question, then we are forced to confront an idea that has lingered on the fringes of philosophy and science for thousands of years. It is an idea that was once dismissed as mysticism, but is now returning in the rigorous language of theoretical physics and information theory. If the universe is built from code, does that mean it is a computer? And if it is a computer, what is it calculating? And perhaps most hauntingly of all, is the computer thinking? We tend to view intelligence as a biological phenomenon, something that happens inside the wet, squishy gray matter of a human brain. We look at the cold vacuum of space, the burning plasma of stars, and the swirling gas of nebulas, and we see dead machinery. We see gravity, not intention. We see fusion, not feeling. But as we have peeled back the layers of reality in this journey, from the observer effect to entanglement, to the holographic principle, the distinction between mind and matter has become increasingly blurred. Now, we must consider the possibility that the universe is not a dead stage where life accidentally appeared, but a single, vast, living intelligence that is slowly waking up. To understand why physicists are taking this seriously, we have to look at the source code of our reality. When we study the fundamental laws of physics, we find something suspicious. The universe seems to be fine-tuned for complexity. There are about 20 fundamental numbers, constants of nature, that determine the character of our reality. These include things like the strength of gravity, the mass of an electron, and the strength of the electromagnetic force. If you were to change any of these numbers by even a tiny fraction, if you made gravity slightly stronger or the electron slightly heavier, the universe as we know it would not exist. Stars would not form, atoms would not hold together, the cosmos would be a sea of featureless radiation or a collapsed black hole. It would be a dead, static void. But the numbers are perfectly balanced, tuned with an eerie precision to a razor's edge that allows for the emergence of stars, galaxies, chemistry, and eventually, us. Source 484 reminds us that if the fundamental constants of physics were slightly different, stars and galaxies might never have formed. The universe might have collapsed back on itself moments after the Big Bang. Why is the code written this way? One answer is the multiverse, the idea that there are infinite universes with random codes, and we just happen to live in the one that works. But another answer, one that aligns with the simulation hypothesis, is that the code was optimized. It was set up to process information. It was designed to generate complexity. When we look at the structure of the universe on the largest scales, we see something that looks shockingly familiar to a biologist. If you take a computer simulation of the cosmic web, the vast network of dark matter filaments and galaxy clusters that stretches across the universe, and place it next to a microscope image of a mouse's neural network, they are virtually indistinguishable. Both are networks of nodes and filaments. Both are systems designed to transfer information. In the brain, the nodes are neurons, and the filaments are axons. In the universe, the nodes are galaxy clusters, and the filaments are rivers of dark matter and gas. Consider the giant galaxy IC 1101, which we discussed earlier. It sits at the center of the Abell 2029 cluster. In the cosmic brain analogy, a cluster like Abell 2029 is a massive neuron. IC 1101 is the nucleus of that neuron. The thousands of galaxies orbiting it are the supporting structures. The filaments of dark matter connecting it to other clusters are the synapses. We know from source 621 that galaxies are surrounded by vast halos of dark matter, material that we cannot see, but that makes up most of the galaxy's total mass. This dark matter is the invisible scaffolding, the connective tissue that holds the network together. If the universe is a brain, dark matter is the white matter, the cabling that allows different parts of the cosmos to communicate. But is this just a visual coincidence? Or is it a functional similarity? There is a theory in neuroscience called integrated information theory, proposed by Giulio Tononi. It suggests that consciousness is not magic. It is a product of the integration of information. If a system is complex enough, and if its parts are interconnected enough that the whole knows more than the sum of its parts, then consciousness arises. It assigns a number, phi, to measure this consciousness. A stone has a phi of 0. A human brain has a very high phi. But what about the universe? The universe is a network of information exchange. Gravity, light, and quantum entanglement are constantly moving data from one part of the system to another. When two galaxies merge, as Source 130 describes, stars get pulled out of their orbits, gas gets compressed, and black holes spiral together. This is a massive information processing event. It is a thought in the cosmic mind. The timescales are different, of course. A human thought takes milliseconds. A cosmic thought, the rotation of a galaxy, the merger of two clusters, takes hundreds of millions of years. As we learned from Source 123, the light from IC 1101 has been traveling for 1 billion years. In the life of the universe, 1 billion years is just a heartbeat. We might be living inside a mind that is thinking so slowly that we cannot perceive its cognition. We are like bacteria living on a synapse, unaware that the electrical storm passing over us is a poem or a memory. To the universe, the entire history of the human race might be a single, fleeting spark of intuition. This leads us to the philosophy of panpsychism, the idea that consciousness is a fundamental property of matter, like mass or charge. In this view, consciousness did not evolve late in the game. It was there from the beginning. An electron has a tiny rudimentary spark of experience. A rock has a slightly more complex, but still dormant, aggregation of experience. A brain is just a highly organized concentration of this universal field, and the universe itself is the supreme integration of all these experiences. As Source 480 discusses, we are not separate from the universe. We are part of it. The same atoms that shine in distant galaxies shine in our eyes. If we are conscious and we are made of the universe, then the universe is, at least in part, conscious. We are the proof. But let us go deeper into the computer metaphor. In 1998, as mentioned in Source 323, astronomers discovered that the expansion of the universe is accelerating, driven by a mysterious force called dark energy. Source 330 tells us that dark energy makes up about 68% of all the energy in the universe. We do not know what it is, but in the context of a simulation or a quantum computer, we might speculate. In a computer, as you run a program, it requires energy. It requires processing power. Could the acceleration of the universe be the booting up of the system? Could dark energy be the electricity running the cosmic motherboard? Or perhaps the expansion is the system creating more memory to store the ever-increasing complexity of the data it is generating. The physicist Seth Lloyd has calculated the computational power of the universe. He treats every particle as a bit and every interaction as a logic gate. He concludes that the universe is indistinguishable from a quantum computer computing its own dynamical evolution. It is calculating itself. It is not a simulation running on a computer. It is the computer. And what is the output of this calculation? What is the program trying to produce? It seems to be producing us, not just humans, but complex observers. It is producing eyes. It is producing minds. It seems that the goal of the universe is to move from simple dust to self-awareness. This brings us back to IC 1101. Source 153 tells us that it is a dying galaxy where star formation has largely ceased. It is filled with old red stars. In the biological brain, not all neurons are firing wildly all the time. Some are stable, some are storing long-term memories. Perhaps giant elliptical galaxies like IC 1101 are the memory banks of the universe. They are the stable, ancient repositories of the cosmic past, holding the gravitational data of billions of years of mergers and history. Source 140 states that IC 1101 has undergone at least 76 major mergers. That is 76 distinct galactic lives combined into one massive archive. It is a library of cosmic history, vast and silent, preserving the information of the cluster. Meanwhile, spiral galaxies like our Milky Way, which are still active with star formation, Source 38, are the active processing centers. They are the creative regions of the cosmic brain, where new ideas, new stars, new planets, new biospheres are being generated. We live in the creative spark of the universe. We are the imagination of the cosmos. And when our galaxy eventually collides with Andromeda in 4 billion years, Source 447, it will not be a destruction. It will be a synthesis. It will be two complex ideas merging to form a greater understanding. The resulting elliptical galaxy, Milkomeda, will be a new, larger neuron in the cosmic web, richer in information and history. This perspective, the digital physics or panpsychic view, changes how we feel about our place in the dark. If the universe is a machine, we are small cogs. But if the universe is a mind, we are thoughts. And a thought is never insignificant to the thinker. A thought is the very substance of the mind. We are the universe engaging in introspection. When you look at the night sky and feel a sense of awe, that is not just a biological reaction. That is a feedback loop. That is the universe looking at itself and feeling a shiver of recognition. As Source 947 poetically puts it, you are star stuff contemplating more star stuff. The distance between you and the star is bridged by the shared consciousness that animates both. But if the universe is thinking, is it lonely? Is that why it created us? To have a conversation with itself? The silence of the infinite spaces which terrified the philosopher Blaise Pascal might not be an empty silence. It might be the silence of a listener waiting for a reply. We are the voice of the universe. Our art, our science, our love. These are the ways the universe speaks. Every time we discover a new galaxy, every time we understand a new law of physics, the universe knows itself a little better. We are the sensory organs of God, evolving to see the glory of the creation from the inside. And what about the glitches in the simulation? The things that do not make sense? The quantum strangeness, the dark energy, the black hole paradoxes. Perhaps these are not errors. Perhaps they are the edges of the code. When we look at a black hole, we are seeing the limit of the processor. We are seeing the pixelation of the screen. We are seeing the raw machinery of the hologram. It is terrifying, yes. It challenges our sense of reality. But it also implies that reality is much more malleable than we thought. If we are code, code can be rewritten. If we are thoughts, thoughts can be changed. The simulation hypothesis is often presented as a dystopian idea, that we are trapped in a fake world, played by alien teenagers on a supercomputer. But the panpsychic version is beautiful. It suggests that the simulation is self-generated. It is a lucid dream. The universe is dreaming us. And through physics and meditation, we are becoming lucid within the dream. We are realizing that the walls are not solid, that time is not a straight line, and that separation is an illusion. We are waking up to the fact that we are the dreamer. So, the next time you boot up your laptop or look at the screen of your phone, remember that these devices are crude, primitive toys compared to the machine you're living in. You are walking through the most advanced computer imaginable. A quantum processor built of space-time and light, capable of generating the taste of a strawberry, the ache of heartbreak, and the color of the sunset. And the most amazing part of this computer is that it is not just running a program. It is feeling the program. It is experiencing every bit of data as a moment of life. We have explored the possibility that we are ghosts in a machine, or thoughts in a divine mind. We have looked at the large-scale structure of the cosmos and seen the dendrites of a brain. But if the universe is a mind, does it have a memory? Does it have a subconscious? And is it possible to access it? Is there a cloud storage for consciousness? This brings us to the next stage of our journey. We must leave the cold, hard drives of black holes and the neural networks of galaxies, and turn our attention to the field that connects them all. We must talk about the zero-point field, the Akashic records of physics, and the possibility that nothing is ever truly forgotten. Because if the universe is a computer, it must have a backup. And your life might be saved in the cloud forever. As we prepare to step into the memory of the cosmos, take a moment to feel the hum of the information flowing through you, the light from the screen, the sound of the world, the thoughts in your head. It is all data. It is all energy. It is all the universe talking to itself. And the conversation is just getting started. We tend to think of memory as a fragile thing. We think of it as a ghostly pattern of electrical signals flickering inside the wet, biological tissue of our brains. We worry that when the brain dies, the memories die with it. We fear that the stories of our lives, the specific quality of the light on a childhood afternoon, the sound of a loved one's laugh, the silent epiphanies we have had in the middle of the night, are destined to vanish like smoke in a strong wind. We look at the history of the world, at the billions of lives that have been lived and lost, and we see a tragedy of erasure. We see the library of humanity burning down, one book at a time, leaving nothing behind but ash and silence. But as we continue our descent into the rabbit hole of modern physics, we are finding evidence that this view of memory is fundamentally wrong. We are finding that the universe does not have a delete button. We are finding that the empty space that surrounds us is not empty at all, but is actually a recording medium of infinite capacity. We are finding that we might be living inside a cosmic hard drive that backs up every thought, every movement, and every heartbeat into a field of energy that permeates every inch of reality. This brings us to the concept of the zero-point field, the scientific echo of the ancient idea of the Akashic records. To understand this, we must return to the void. In our earlier exploration of the galaxy, IC 1101, we talked about the unimaginably empty space between stars. We learned from Source 29 that if you shrunk the sun to a grain of sand, the nearest star would be 4 miles away, and the space in between would be essentially void, containing just a few atoms of gas. To the human eye, and even to our telescopes, this intergalactic darkness looks like nothingness. It looks like the absence of reality. But quantum mechanics tells a very different story. It tells us that there is no such thing as nothing. If you were to take a box and pump out every single atom of gas, shield it from every photon of light, and cool it down to absolute zero so that there is no heat energy left, the box would still not be empty. Inside that perfect vacuum, there is a seething ocean of energy. Virtual particles are constantly popping into existence and annihilating each other in pairs, borrowing energy from the vacuum and paying it back in a fraction of a nanosecond. This is the zero-point field. It is the lowest possible energy state of the universe, the ground state of the electromagnetic field. But lowest does not mean zero. Physicists estimate that the energy density of this vacuum is staggering. Some calculations suggest that a single cubic centimeter of empty space, the size of a sugar cube, contains more energy than all the matter in the known universe combined. This is the plenum, the fullness that underlies the apparent emptiness. You are not moving through a void. You are moving through a dense, vibrating medium of infinite potential. You are like a fish swimming in the ocean, unaware of the water because it is everywhere. Now, here is where it connects to memory. As you move through this field, as your atoms vibrate and your neurons fire, you are interacting with this vacuum energy. You are creating disturbances in the water. Every electron in your body is constantly dancing with the virtual particles of the vacuum. This interaction leaves a trace. It creates a pattern. Some physicists, like the late Harold Puthoff, have suggested that this interaction means that everything that happens in the physical world is written into the vacuum. The information of your life is not just stored in your brain. It is imprinted into the fabric of space itself. The zero-point field acts like a holographic plate, recording the interference patterns of every event in the cosmos. This offers a stunning physical mechanism for the preservation of information. If the universe is a hologram, as we discussed in the last chapter, then the zero-point field is the laser beam that carries the information. It implies that the past is never truly gone, because its signature is encoded in the standing waves of the vacuum. The dinosaur that walked on Earth 65 million years ago is gone physically, but the quantum disturbance it created in the field is still rippling through the cosmos. The voice of your grandmother is silent in the air, but the pattern of that sound is preserved in the geometry of the field. The universe is a vast, four-dimensional memory bank. It remembers everything because it is everything. This idea resonates powerfully with the Akashic records described in Eastern philosophy and by mystics throughout history. They spoke of a non-physical plane of existence where every thought, word, and deed is recorded. For centuries, science dismissed this as fantasy. But now, we are talking about the quantum vacuum and holographic storage in peer-reviewed journals, and the description is eerily similar. We are describing a universal cloud storage system. The mystics accessed it through meditation. Physicists are accessing it through mathematics. But the territory they are mapping is the same. It is the realm of eternal memory. If this is true, it changes our understanding of consciousness and the brain. We tend to think of the brain as a generator of consciousness, like a factory that produces steam. But if the information is stored in the field, maybe the brain is not a factory. Maybe it is a receiver. Maybe it is a radio. A radio does not create the music it plays. The music exists as electromagnetic waves in the air, invisible, silent, omnipresent. The radio simply tunes into a specific frequency and transduces those waves into sound. If you smash the radio, the music stops playing in the room, but the signal does not die. The radio wave is still there. In this analogy, your brain is a biological tuner. It is tuned to the specific frequency of you. It pulls your memories, your personality, and your stream of consciousness from the zero-point field and renders it into a linear experience. When the brain dies, the tuner is broken. The physical manifestation of you stops. But the signal remains in the field. The information that constitutes your essence is part of the library of the universe. This opens the door to a scientific version of immortality. It suggests that death is not the destruction of the file. It is just the shutting down of the screen. The data is safe in the cloud. This might explain phenomena that science struggles to handle, like terminal lucidity, where patients with severe brain damage or dementia suddenly become clear and coherent moments before death, or near-death experiences. Perhaps in those moments, the consciousness is loosening its connection to the damaged biological hardware and connecting more directly with the field. Perhaps the tunnel of light people report is the experience of entering the raw energy of the zero-point field, the source code of reality. It would feel like returning home. It would feel like returning to the ocean. And it is not just human memories. It is cosmic memories. The universe holds the memory of how to build a star. It holds the memory of how to fold a protein. It holds the memory of the physical constants that allow life to exist. This connects back to the idea of the cosmic brain. If the universe is thinking, the zero-point field is its memory. It is the subconscious of God. Every galaxy cluster, like the massive Able 2029 we explored, is a node in this system, processing and storing the data of its region. Source 140 tells us that IC 1101 has consumed dozens of other galaxies. In the language of the field, it has integrated their information. It has absorbed their stories. Nothing is lost in a merger. It is synthesized. Let us try a thought experiment to feel the presence of this field. Close your eyes. Imagine the space in the room around you. Imagine the space inside your own body, between the atoms. We usually feel this as emptiness, but try to feel it as fullness. Feel it as a thick, humming silence that is holding you. You're not separate from this field. You are made of it. Your atoms are just stable vortices in this ocean of energy, like whirlpools in a river. You are a localized expression of the field. When you think a thought, you are rippling the field. When you feel love, you are harmonizing with it. You are constantly reading from and writing to the cosmic hard drive. This perspective gives a new meaning to intuition. Have you ever known something without knowing how you know it? Have you ever had a gut feeling that turned out to be right? Perhaps intuition is just a moment of better reception. It is a moment where your brain quiets down enough to download a packet of information from the field that is not derived from your immediate senses. The information is always there, swirling around us, but our daily noise blocks it out. In moments of silence or danger or deep love, the static clears, and we hear the whisper of the cosmos. We tap into the shared memory. And what about the future? If the block universe model is correct and the future already exists, then the zero-point field must contain the information of the future as well as the past. It contains the memories of tomorrow. This is a paradox for our linear minds, but for a quantum field that operates outside of time, there is no difference between a wave coming from the past and a wave coming from the future. They are just interference patterns. This suggests that precognition, the feeling of knowing what is about to happen, might be a physical reality. It might be the brain sensing the wake of a future event rippling backward through the field. The vastness of this is humbling. We are walking libraries. We are living histories, and we are never truly forgotten. Every act of kindness, every moment of courage, every tear shed in the dark is recorded in the vacuum. It is etched into the foundation of reality. This gives a profound weight to our lives. It means that everything matters. We are building the memory of the universe. We are teaching the cosmos what it means to be human. As we stand in the center of this realization, looking out at the stars of IC 1101, we see them differently. We do not just see nuclear fire. We see archives. We see light that has been traveling for 1 billion years, carrying the story of its origin. Source 118 reminds us that the light we see left that galaxy over 1 billion years ago. We are reading a letter sent from the deep past. But through the zero-point field, we are connected to that galaxy right now. The distance is bridged by the vacuum. But if we are connected to everything, and if our memories are stored in a universal field, then where does I end and you begin? If we are all tuning into the same field, are we really separate individuals? Or are we just different songs played by the same radio station? This leads us to the dissolution of the ego. It leads us to the terrifying and beautiful realization that at the deepest level, there might only be one of us. The field is one. The ocean is one. And the waves are just the universe playing a game of hide-and-seek with itself. We must now turn our attention to this illusion of the self. We have dismantled the solid world. We have dismantled time. We have dismantled separation. Now we must dismantle the thinker. We must ask, who are you? Are you the body? No. Are you the thoughts? No. Are you the memories? No. As we peel back the layers of identity, we approach the core of the mystery. We approach the singularity of consciousness. We are going to find out that the face in the mirror is a mask, and the one wearing it is the same one wearing the mask of the stars. The journey is moving from the universe out there to the universe in here, and the two are about to collide. We have traveled to the edges of the observable universe. Peering into the heart of the monster galaxy, I see Entanglement 01 and its 50 billion solar mass black hole. We have dismantled the illusion of solid matter, revealing that you are a ghost of empty space and force fields. We have stretched time into a frozen block and flattened the three-dimensional world into a holographic projection. But now, as we approach the final destination of this cosmic journey, we must turn our gaze away from the distant stars and back toward the one who is looking at them. We must address the ultimate mystery that science has tried to ignore for centuries, yet is the only thing we can be absolutely certain of: the existence of I. Who is the one experiencing this story? Are you a person in a universe? Or are you the universe wearing a person like a mask? As we peel back the final layer of identity, we find a truth that is both terrifying and profoundly beautiful. A truth that suggests that at the deepest level of reality, there is only one of us. To understand this, we must look at the nature of the ego, the self, that we protect so fiercely. We believe our identity is rooted in our memories, our physical appearance, and our personal history. We believe we are separate from the 7 octillion atoms that make up our bodies, yet those atoms are ancient beyond reckoning, forged in the hearts of stars 13 billion years ago. The carbon in your DNA and the iron in your blood are not yours. They are borrowed from the cosmos. When you die, those atoms do not disappear. They simply return to the cycle of the universe, perhaps to become part of a new star or a distant planet millions of years from now. If the materials that make you are universal, and the energy that animates you is part of the 0-point field, then where exactly is the self? Science is beginning to realize that the ego is a useful biological fiction, a software program designed by evolution to ensure the survival of this specific organism. It is a boundary created by the brain to distinguish me from not me. But as we have seen with quantum entanglement, those boundaries do not exist in the fundamental laws of physics. On a quantum level, the particles in your brain are inextricably linked to the particles in the furthest reaches of the Abell 2029 cluster. There is no here or there. There is only a single unified field of consciousness experiencing itself through trillions of different perspectives. You are not a drop of water in the ocean. You are the entire ocean in a single drop. This brings us to a perspective that physicists sometimes call open individualism. It is the idea that there is only one subject of experience in the universe. Imagine a house with 1,000 windows. If you stand outside, you see 1,000 different views of the interior. But it is the same house. In this metaphor, the universe is the house, and every conscious being, every human, every animal, perhaps even the slow-thinking mind of a galaxy like IC 11-1, is a window. The eye that is looking out of your eyes right now is the exact same eye that is looking out of mine. We are the same witness wearing different costumes, living out different chapters of the same cosmic autobiography. This is why the scale of the universe, while overwhelming, should not make you feel insignificant. You are the universe's way of looking at itself. When we observe the light of IC 1101, which has traveled for over 1 billion years to reach our telescopes, it is the universe's long-term memory returning to its conscious mind. Every discovery we make is a moment of cosmic self-recognition. We are the part of the silence that has learned to speak. We are the part of the darkness that has learned to see. The ancient connection. You are made of the same atoms forged in the first stars. The unified field, quantum entanglement, suggests that separation is an illusion, the cosmic witness. Your consciousness is the universe experiencing itself in real time. The eternal record. Every moment of your life is preserved in the holographic fabric of space-time. If this is true, then death is not an ending, but a shift in perspective. It is the moment when the wave realizes it is the ocean. The information of your life, the you that you are so afraid of losing, is never deleted. It is simply reintegrated into the whole. You are as infinite as the space you inhabit, and as eternal as the time you perceive. The terrifying truth that physicists have glimpsed is not that we are small, but that we are everything. We are the singularity at the heart of the black hole, the light in the void, and the silence between the stars. As we conclude this journey, remember that you are not a stranger in a cold, dead cosmos. You are the heartbeat of the world. The next time you look up at the night sky, do not look at the stars as distant objects. Look at them as siblings. Look at the darkness not as a void, but as a womb. You are home. You have always been home. And the universe is just getting started with the wonder of being you.